Good morning.
Hi.
Hello. All right, welcome back. Last time we were together, we were talking about the exponential function, and we did all this craziness, and we had some very interesting numbers show up, and we were discussing how to evaluate some of these functions, and we did them all with positive exponents, and everything was happy. Today, we're going to be doing much the same thing, but after we're done evaluating this function at several different points, we're going to be graphing those points. And we can't graph just the positives because the negatives are also part of the picture. And so today, you're going to learn how to handle these evaluations with negative exponents.
Okay,
Right?
so like the line above the numbers is the negative?
Yeah, so it's not something that I've made unless I've messed it up. I have made it too skinny for the negatives and they turned into hats. Sorry. So can you please make them actual negatives and not hats? Because sorry. All right, let's go ahead and start filling out the first one. So the first one says I'm going to take 2 and I'm going to raise it to this power, which is a negative 6. And so now I have 2 to the negative 6. And right now your brains are going, what? Like, how do I multiply due to itself negative 6 times? Like, this doesn't work. What? Okay, here's how you handle this. When you've got a negative exponent, take the base and flip it and make it the reciprocal. Okay, so we took the base, which was 2, thinking about it as 2 over 1, and took the reciprocal of that base. So now my base is 1/2. And then the power I'm going to apply to it is the power I had originally, but without the negative sign.
So we turn the whole number into a fraction?
So we flip the base, so if it's a whole number, it becomes a fraction, yes.
That way it cancels the negative?
That way it gets rid of the negative, so that way I can work with it normally in the way I can think about it. It's called the negative exponent, or the reciprocal law of exponents. I think it's called the reciprocal law of exponents. Okay, is that? It takes away the negative on the exponent. Yep. Stay with me, girls. All right, sounds good? And now I can apply that power on the fraction the way I've done all the others. And now I can think 2 to the 6, which is so much easier than 2 to the negative 6, right? So 2 to the 6 is 2 times 2, which is 4, times 2,
8,
times 2,
16,
times 2,
32,
times 2.
64.
And leave it as a fraction. Okay, we're going to do the same thing here. This is 2 to the negative 2. To get rid of that negative in the exponent, I'm going to take the reciprocal of the base. I'm going to apply the power back to the new reciprocal without the negative. I'm going to apply the power to numerator and denominator. I'm not writing very neatly today, am I?
Wait, is that
It's a 4, yeah.
Oh, snap. I
It's not a 41. It's a 4. Okay, this one is 2 to the negative 1. Take the reciprocal of the base, apply the power as a positive. Anything to the first power is itself. This is something to the 0 power. Now, many of you got to this point, I think, yesterday in your homework. I had a couple of questions, and so thank you for those. Where you were like, oh my God, this thing is to the 0 power. What is that? Is that 0? The answer is, no, it's not 0. Anything to the 0 power is 1. I don't care what it is. It could be 2. It could be 1/2. It could be 1,000,000 to the 0 power is 1. It could be frog to the 0 power. It'll be 1, which is weird. We took an animal and we turned it into a number. But, you know, math can get weird like that. Okay. All right, so this is 2 to the first, 2 to the second, and 2 to the third. You guys are feeling really comfortable with these numbers. So there they are. And now I have to graph that mess. I know, right? That's how my brain feels. I'm going to draw this graph in my blue pen so that it stands out and it looks different from the other graph I'm going to have to put on here. Normally, when you have been taught how to graph, you've been taught to start at the top of the table of values and work your way down.
But we're gonna work our way up.
But I'm going to start at the bottom, work my way up, because the numbers on the bottom are whole numbers and they're easier to think about than starting with weird fractions. Okay? So, x is 3, y is 8, x is 2, y is 4, 1, 2, 0, 1. Okay, -1, I'm at half, so I need to go halfway between 0, 1 and put my dot. At -2, I'm at 1/4. 1/4 is half of the distance between 0 and half. So I'm going to take this distance. I'm going to use my pink pen to show you. So there's the halfway line. So from 0 to half of that space is 1/4. Okay? And I can keep cutting that space, that leftover space, in half as many times as I need to in order to get down to 1/64. But if you're already imagining how small those slices are, this fat marker I'm using isn't going to be able to do that justice. Okay? I'm just not going to be able to do it. It's too fat. So instead, what I'm going to do, and I'm going to zoom in real tight so you can see what I'm about to do here. On the -6, which according to my calculation should be at y equals 1/64, I'm going to put a dot just as close as I can get it to the x-axis. Right? Let me try that again. I put a dot as close to the x-axis, y equals 0 line, that's what I was trying to do, as I can get without actually touching it. Okay, there's a little bit of space there. All right? I can talk. Now that I've got all my points, my goal is to use a pen, and I'm going to use one that's a little thinner, but the same color. I'm all fancy with my pens today. And I'm going to try to connect these dots as smoothly as I can in a nice, beautiful curve. And my goal is over here on the left to try to swoop it down so that it looks like it continues on for forever without getting to 0, touching 0. So we're going to get really close to this line, but we're not going to touch the 0 line, okay? So I'm going to start here, and I got to like hold my breath for this. Oh, God. That's like,
Oh man, I messed up. Oh man.
wow. It looks like it's basically flat at this point. But we know it's continually going down. But in order to show that this continues on for forever, I have to put an arrowhead on it. Do you see the problem if I just put like a normal arrowhead?
Mm-hmm.
One of the parts of the arrowhead is going to crash through that x-axis, and it's going to look like the line is meant to go through that, and we don't want it to look like that. So here's the workaround I developed for myself. I don't know if any other math teacher tells you to do this. I don't even know if they draw it this way. But this is how it made sense to my head to make sure that I knew, dude, don't cross this line. Okay? I'm going to draw only half an arrowhead. Like that.
Ooh.
So it's like I'm going to go whoosh, and I'm just going to keep sliding. Okay?
All right.
All right, now that I've got that side of the graph taken care of, I'm going to, holding my breath, try to swoop. Okay. There it is. Let's try to get this camera to focus. Beautiful. I'm going to label my function. F of x equals 2 to the x. And it's done. My beautiful graph, I can see where it's sliding down and not touching that y equals 0 line. Awesome. Let's repeat for this one. So we're going to do it again. This time, though, the base is a fraction, which means this thing is a It's a decay. So we know that this thing is going to, as you move from left to right, start high and slope down, okay? All right, so let me zoom in and let's do these calculations. Again, we're going to have potentially negative exponents. Okay, so my function says 1/2 to the negative 6th power. I have a negative exponent. To deal with negative exponents, I want to get rid of that negative. Do that by taking the reciprocal of the base. So I flip the base on its head, and then I'm going to apply the positive version of the original power. This is the same as 2 to the 6th power, and you've already told me that 2 to the 6th power was 64. It feels almost like cheating, getting rid of negative exponents this way, doesn't it? Yeah? It's not, because that's the law. It really is, because it's called the reciprocal law. So you're following the law. You're good. Follow the law for the rest of your table, please. I've hit a something to the 0 power.
1.
Exactly.
Yes, even though there's a number like in front of it.
Ah, great question. So, you're talking about, let me scoot over this way. So you're talking about, say, if I had like this, right? Yeah, so what would happen here is I have to evaluate this portion of it first, so that becomes 1. And then I'd multiply by this coefficient out here.
You know, what if this is like that, and then like what if there's like a -4 at the end?
Then there's a -4 at the end. Yeah. He's like, thank you for the answer to number 4. I've encountered something to the 1 power. Anything to the 1 power is itself. Good, good, good. All right. Got all my numbers generated. Okay, going to graph this function. Going to graph it in red because I'm doing it on the same bit of graph paper and I want it to look visually different from the blue.
Very last one?
The very last one, it is an 8, yes, sir. Are you having trouble seeing a little bit?
No, I thought it was a 3.
Oh. Because if you are, I can turn this around and...
No, it's okay.
Okay.
Thank you.
You're welcome. All right, going to graph all these points. I am going to start at the top of the table of values and work my way down. Again, because the top has the whole numbers and the bottom has the fractions. All right, so the first one, -6, 64. Yeah, my graph does not go to 64, so
We can just put it like,
I'm going to skip it for now because I can graph the rest of the points. So -2 is at 4. -1 is at 2. 0 is at 1. 1 is at half. 2 is at 4th. 3 is at 8th. And I've got that swoopy down thing happening again. All right. I've got enough information. Again, I have this swoop. So I'm going to make sure that when I get to this swoop that I'm going to put the same sort of half an arrow. Okay? So that way I don't confuse myself and make me think that it's going to crash through that. I don't think I could get any closer without actually touching the line. Which one? Okay. Oh, okay. No, that's good. It's a wonderful conversation. All right, looks good. All right. Real quick, let's pull back some information from
snap it.
yesterday and from previous times together. Looking at just the blue one, is it a function?
Yes.
What is its domain?
Our real numbers.
What's its range?
Yeah.
No.
It's not all real numbers because it's not ever.
Oh.
The one and then. No.
I see where you're going with it. You were hitting. Yeah, you were heading toward interval notation, and I think you would eventually get to the right spot. Jeff over here was saying that it's all the numbers in the positive region. It's everything that's bigger than 0. So we're going to take the easy way out and just say y is greater than 0. Classify this thing. Is it a growth or is it a decay?
Growth.
Beautiful. You know it's a growth because as you're looking at the picture, moving from left to right, we see it shooting off higher and higher. You can also look at the base and go, oh, that's bigger than 1. All right, look at the other function that we drew. I've called it a function, but is it a function?
Yes.
How do you know?
The vertical line.
It passes the vertical line test. You all are amazing. What's its domain? And its range?
Greater than. No.
Greater than 0.
Greater than 0. What's greater than 0?
One.
Perfect. Y. And then classify this one.
Decay.
No.
It's a decay.
Left to right.
Yeah, when you look left to right, this thing is swooping down and getting smaller and smaller. Good. Now, yesterday when we were looking at this thing, we were exploring that line that it was swooping down, and we discovered this thing's never going to hit 0. I said that line has a special name, and we'll talk about it later. Hi, it's now later. So I'm going to highlight that line that these graphs are swooping closer to. We do that with a dotted line to show that that graph is not going to touch that line, okay? This line, which is my y equals 0 line, is called the asymptote. And now you can make people think you've insulted them.
You're like an asymptote.
Don't be an asymptote. I'd like to emotionally reach you and have this connection with you, okay? So don't be an asymptote and don't put yourself where you cannot be emotionally reached.
Oh.
Stop being an asymptote.
I'll try this. That's what
So now when you say that to a friend, they're going to be like, what'd you call me? And you're like, dude, let me show you this channel. I'll explain everything. All right, sounds good?
Yes.
All right, let's come down to here. I want to play with this one. I want to play with this one. All right, so same thing as before, right? You generate a bunch of values, and I'm going to do that fairly quickly because I feel like you guys are kind of really understanding how to do this. Okay, this goes back to your earlier question, what happens if you've got a plus or a minus number at the end? This is what's going to happen. So I'm going to apply the power. It's a negative power, so I need to take the reciprocal. All right, so this is going to be 1 and 1/2. Okay?
Oh.
All right? You can translate that into a decimal for yourself if you want in your head to graph it, but I'd like your answers to stay in fractions, please. All right, I'm going to quickly fly through the rest of these. Please do stop me if you're not sure where I'm generating a number from. Or if I've, added wrong, that too. Oh. I was adding wrong. Okay, give you guys a couple seconds there to double check my arithmetic. 1 plus 2 is hard. I did okay this term? 100%? Oh, good. I'm getting straight A's this semester. All right, I'm going to go ahead and graph this. Change of pace. I'm going to do this one in pink because why not? All right, going to graph this one. -3, 1.5. -2, 2. -1, 3, 0, 5, 1, 9. All right, so there are my points. The issue is that I don't really know where the asymptote is. Right? I don't see it. But I want you to see something. Look right here. 2, -1, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And up here I have, come on, focus, thank you. 2 to the -1, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. They're the same ones that I have right here. Do you notice? Okay. So here on the 2 to the -1, originally my parent function is a half. And now it's a half plus 1. Here it's a 1. Now it's a 1 plus 1. This was a 2. Now it's a 2 plus 1. Do you see how all of them are plus 1? So this stands to reason that maybe the asymptote, y equals 0, also has a plus 1. So maybe the asymptote isn't at 0, but rather at 1. If I were to put this in a graphing calculator, or if I were to continue getting more and more negative exponents on this thing, I would see that this would tend toward 1. I would get 1 plus and then some number that was really, 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 really small. Yes? Make sense? All right, so now I know where my asymptote is. I know to avoid the asymptotes. Good in math and in life. He got it. She did too. And I'm going to label this function f of x. Look. There was the asymptote, sitting right there for us to see. So the asymptote is at y equals 1. Where would you guess the asymptote is for this one?
4.
Give me the whole equation.
Y equals
Gorgeous. For this one, what's the equation for the asymptote? Beautiful, thank you. And this one, the asymptote is at y equals -2.
Wait, Miss, can you put it back to this one?
Sure, I'll slide it over just a little bit like that. Trying to get my camera to focus. Awesome job, guys. Do you guys have any other questions I can answer for you on this item or anything we covered today? All right, we had a lot of shaking their heads or just immediately jumping to the homework. So thank you guys so much. We'll see you next time.